Get ready for a close encounter with one of the most awe-inspiring natural phenomena in our solar system. Join us as we journey through Jupiter's tumultuous atmosphere to explore the legendary Great Red Spot. This massive storm has been raging for centuries, and its swirling clouds hold fascinating secrets about the dynamics of our solar system's largest planet. With stunning images captured by NASA's Juno spacecraft, this video will take you on a breathtaking ride through the tumultuous weather patterns of Jupiter's atmosphere. Don't miss out on this incredible opportunity to witness the power and beauty of the Great Red Spot. Watch the amazing revelations from our exploration of Jupiter. What is the Great Red Spot? The Great Red Spot is a persistent high-pressure region in the atmosphere of Jupiter, producing an anticyclonic storm that is the largest in the solar system. Located 22 degrees south of Jupiter's equator, it produces wind speeds up to 432 km/268 miles per hour. Observations from 1665 to 1713 are believed to be of the same storm. If this is correct, it has existed for at least 358 years. It was next observed in September 1831, with 60 recorded observations between then and 1878, when continuous observations began. Observation history. The Great Red Spot may have existed since before 1665, but it could also be the case that the present spot was first seen only in 1830 and well studied only after a prominent apparition in 1879. The storm that was seen in the 17th century may have been different from the storm that exists today. A long gap separates its period of current study after 1830 from its 17th century discovery. Whether the original spot dissipated and reformed, whether it faded, or if the observational record was simply poor is unknown. The first sighting of the Great Red Spot is often credited to Robert Hooke, who described a spot on the planet in May 1664. However, Hooke's spot was likely not only in another belt altogether, the North Equatorial Belt, as opposed to the current Great Red Spot's location in the South Equatorial Belt, but also that it was the shadow of a transiting moon, most likely that of Callisto. Far more convincing is Giovanni Cassini's description of a permanent spot the following year. With fluctuations in visibility, Cassini's spot was observed from 1665 to 1713, but the 118-year observational gap makes the identity of the two spots inconclusive. The older spot's shorter observational history and slower motion than the modern spot make it difficult to conclude that they are the same. Exploring the Great Red Spot. The Great Red Spot has been observed since 5 September 1831. By 1879, over 60 observations were recorded. After it came into prominence in 1879, it has been under continuous observation. In the 21st century, the Great Red Spot has been observed to be shrinking in size. At the start of 2004, its longitudinal extent was approximately half that of a century earlier, when it reached a size of 40,000 kilometers, 25,000 miles, about 3 times the diameter of Earth. At the present rate of reduction, it would become circular by 2040. It is not known how long the spot will last, or whether the change is a result of normal fluctuations. In 2019, the Great Red Spot began flaking at its edge, with fragments of the storm breaking off and dissipating. The shrinking and flaking fueled concern from some astronomers that the Great Red Spot could dissipate. Other astronomers believe that the apparent size of the Great Red Spot reflects its cloud coverage and not the size of the actual underlying vortex, and they also believe that the flaking events can be explained by interactions with other cyclones or anticyclones, including incomplete absorptions of smaller systems. If this is the case, this would mean that the Great Red Spot is not in danger of dissipating. A smaller spot, designated Oval Ba, formed in March 2000 from the merging of 3 white ovals, has turned reddish. Astronomers have named it the Little Red Spot or Red Junior as of 5 June 2006. The Great Red Spot and oval Ba appeared to be approaching convergence. The storms pass each other about every 2 years, but the passings of 2002 and 2004 were of little significance. Amy Simon Miller, of the Goddard Space Flight Center, predicted the storms would have their closest passing on 4 July 2006. She worked with Imke de Pater and Phil Marcus of UC Berkeley and a team of professional astronomers since April 2006 to study the storms using the Hubble Space Telescope. On 20 July 2006, the two storms were photographed passing each other by the Gemini Observatory without converging. In May 2008, a third storm turned red. The Juno mission. On 25 February 1979, when the Voyager 1 spacecraft was 9,200,000 kilometers, 5,700,000 miles, from Jupiter, it transmitted the first detailed image of the Great Red Spot. Cloud details as small as 160 kilometers, 99 miles, across were visible. The colorful, wavy cloud pattern seen to the left, west, of the red spot is a region of extraordinarily complex and variable wave motion. The Juno spacecraft, which entered into a polar orbit around Jupiter in 2016, flew over the Great Red Spot upon its close approach to Jupiter on 11 July 2017, taking several images of the storm from a distance of about 8,000 kilometers, 5,000 miles, above the surface. Throughout the Juno mission, the spacecraft continued to study the composition and evolution of Jupiter's atmosphere, especially its Great Red Spot. TMPERT. Jupiter's Great Red Spot rotates counterclockwise, with a period of about 4.5 Earth days or 11 Jovian days in 2008, measuring 16,350 kilometers, 10,160 miles, in width as of 3 April 2017. Jupiter's Great Red Spot is 1.3 times the diameter of Earth. The cloud tops of this storm are about 8 kilometers, 5.0 miles, above the surrounding cloud tops. Infrared data has long indicated that the Great Red Spot is colder, and thus higher in altitude, than most of the other clouds on the planet. The upper atmosphere above the storm, however, has substantially higher temperatures than the rest of the planet. Acoustic waves rising from the turbulence of the storm below have been proposed as an explanation for the heating of this region. This Great Red Spot is still present in Jupiter's atmosphere. More than 300 years later, it is now known that it is a vast storm, spinning like a cyclone. Unlike a low-pressure hurricane in the Caribbean Sea, however, the red spot rotates in a counterclockwise direction in the southern hemisphere, showing that it is a high-pressure system. Winds inside this Jovian storm reach speeds of about 270 miles per hour. The long lifetime of the red spot may be because Jupiter is mainly a gaseous planet. It possibly has liquid layers, but lacks a solid surface, which would dissipate the storm's energy, much as happens when a hurricane makes landfall on the Earth. However, the red spot does change its shape, size, and color, sometimes dramatically. Such changes are demonstrated in high-resolution wide-field and planetary cameras, 1 and 2 images of Jupiter obtained by NASA's Hubble Space Telescope and presented here by the Hubble Heritage Project team. The mosaic presents a series of pictures of the red spot obtained by Hubble between 1992 and 1999. In conclusion, exploring Jupiter's Great Red Spot with NASA's Juno spacecraft has opened up new horizons in our understanding of the largest planet in our solar system. The mystery surrounding the stormy atmosphere of Jupiter has been unraveled through the Juno mission, revealing the fascinating secrets hidden beneath its cloud cover. With the latest technology and ongoing research, we can only hope to continue uncovering the mysteries of our solar system and beyond. Subscribe to our channel, or you will miss out on our interesting videos.